Hello everyone, my name is Gautam Datta and I am doing MSc in machine learning. My topic is to create caption by extracting features from image and videos using deep learning model. In the next section, I'll describe what all topics I'm covering as a part of the thesis work. So, as a part of the thesis work, I am covering the introduction section, which covers the background and what is that image caption is and how the video caption is getting generated. Those information, and next, doing the literature review, which talks about the past work that has been done by the various researchers in the field of machine learning and especially for images and video analysis. And next, I'll be covering the problem statement, which talks about what exactly the problem I'm trying to resolve in this thesis work. Next, to resolve those problems, what methodology I have used and what deep learning methodology techniques that has been used, that is covered in the next section. Then the results and discussion sections talks about that what is the output that has been generated out of the methodology that has been applied, and finally the conclusion and the future work, which talks about that what we can do and what is in the can be done in the future. That is basically the extension of the proposed research work that has been done by me. And finally, I'll talk about in the next section about the introduction of this machine learning thesis work that has been done by me. Image caption generation, or the generation of sentence from the image, is a challenging work for the artificial intelligence problem, where the textual description is generated from a given photograph. Generating a description from the image by forming the correct sentence is called image captioning. The captioning automatically generating the textual description by using the artificial neural network from an image or the video frame is the main task of the thesis work. The caption generation requires the computer vision to understand the content of the image by identifying the features or objects that are inside the image, and a language model from the field of natural language processing to turn the image into the words, into the right word and a sequence to form the correct sentence. Image captioning requires a lot of work which recognize the main object, attributes and their relationships in context with the image. It also needs to generate the syntactically and semantically correct sentence by referencing those extracted features. The deep learning methods have demonstrated the capability to generate the state-of-the-art result in caption generation problem. The generated output is then from the deep learning methods is expected to describe the single sentence which is shown in the image. The features, that is the features of the image, the object presence in the image and their properties and the actions that have been performed to automate the same. When captioning comes to the video captioning, it's basically identifying the scene from the video. There are various methodology techniques developed using AI and ML in the past few years. Those are basically suffers from accuracy and in terms of not very effective and correctness. So the pain point on the video captioning is that one needs to observe the video multiple times to come up with a caption manually if someone has to do. If also someone needs to refer a specific scene or the video multiple times, then they have to do multiple times by observing the specific frame or the video. It's basically time consuming and difficult task. So machine learning techniques, this helps to generate the sentences and sentences from the videos automatically. So so machine learning techniques, I have used it to generate the sentence from the video by converting the video into the keyframes out of it, and then by by applying those images or going through the images, extracting the features and generating the sentences. The main motivation of this work is basically when I look into the automatic driving, which is one of the biggest challenge nowadays, where the captions or the scene around from the car that can be used to interpret the image, and that can be fed into the another system to take an action on it. Another challenging thing is that to create a beautiful product for the physically disabled people who can, who can understand by just hearing the voice, by generating basically the text out of the image, and then feeding into the another system which can generate the voice. So that will be helpful for them if they are not able to see things by their eyes. In case of CCTV camera, and that has been used for generating the image relevant captions, and that can raise alarm as soon as there is malicious activity going on or somewhere in the image. And automatic captioning helps the image search for a specific section and convert that into caption. So development of intelligence, security, and surveillance system also as another motivation for this work. Aims and objectives of this is comes from that generating the image caption by using the various deep learning model, using Flickr 8K, 30K dataset and video frames. Preparing clean and text data and perform some basic learning activity, and extracting the features out of the image, and creating vocabulary of all the unique words that is present in the database, extract the features from the image and generating the text out of it, use the predefined model to generate the sentences from the images, and then use that extract the keyframes from the video to generate sentence for the generated frames, and finally test out the various the performance of the model, how good the performance is. Now, next section I'm going to talk about is the literature review. In the literature review section, I have started various literature that was published in various authors, and I've seen that this whole literature review is divided into a few groups. Like deep learning, first of all, we look into the various deep learning techniques that needs to be generated syntactically and semantically correct sentences. The study shows that deep learning based techniques that are capable of generating syntactically and semantically correct sentences, and this also captures how deep learning models generate syntactically and semantically correct sentence with high accuracy. The other approaches are basically various approaches to generate the sentence from the image. Because in 2020, some researchers have constructed a prototype of synthetic 3D face that shows the emotion associated with the text-based speech. In 2018, encoder and decoder this framework named as reference-based long-short memory by assigning the differing weights to the words and accordingly and to define the correlation between the words and images. And in 2017, they have used some image retrieval by dense captioning for complex image retrieval into the dense captioning and generating the sentences out of it. And in 2017, there was a research work that shows that show and tell model to provide a realistic solution for situational awareness that can be useful for decision making during the disaster monitoring using the social media like Twitter. And in 2016, also we see that a deep learning model, a hierarchical approach that has been used by using the neural network and for generating the descriptive images and paragraphs. The model decomposes both the images and paragraphs into the constitutional parts, detecting the semantics and regions in images for creating the sentences. And there are a few more like various architectures that was used for generating the image captioning. You can see that 2018, the contents of the image are generated automatically when involved various computer vision, NLP, and CNN as used for feature extraction, RNN as used for sentence generation. In 2016, we see that the the architecture for image caption generation using bottom-up and top-down approach. CNN and LSTM architecture is used for modeling. After the NIC architecture is used to generate the caption. In 2016, also they developed a parallel Nobel-based LSTM architecture for image caption generation with improved efficiency. Andrej Karpathy and Fifi in 2013 developed a deep convolution neural network large-scale visual recognition. Images are fed into the input as an RNN, and then RNN is used to predict the words into the made the sentence. Object detection using the deep learning techniques that has been in 2015. There are a few research work that was done on this topic, and it developed a region-based proposal network that shares the full image convolution features with the detection and simultaneously predict the object and scores at each position. In 2012, the paper proposes another paper proposes a novel prescribed context-based approach to detect the emotion from the text. In 2015, developed an object detection network which depends on region proposal algorithm to hypothesis object and object locations. And in caption generation from the videos, we see the various methodologies for generating the caption. And there is a keyframe network, a keyframe-based method that was employed. Should they use that boundary detection techniques, a bag of visual words based on local key points and keyframe extraction and semantic concept detection. In 2014, a content-based video retrieval system was developed, and it basically looks like video segmentation, keyframe extraction, content-based images and videos captured in from the other sources such as internet and news articles do not have description, but the human can largely understand by manually observing it. So it's very difficult to write the caption manually, and for the large set of images and videos, the description may vary from individual person to person, perception, mood, interpretation, and at the time of observation, there's sometimes so it sometimes leads to coming up with the inaccurate error or imperfect description of the images or video. To identify and refer to a specific video frame is a very tedious job. So objective is to build the application which can cater to the issue of generation of sentence from the video automatically. To overcome the issue of generating the automatic sentence by using the deep learning model has been developed. The sentences are generated by extracting the features by using the CNN, and then it is fed to LSTM network to generate the next sequence of word, and finally generate the sentence out of it by arranging the words in a further sequence. In case of video files, the video input is fed into the keyframe extraction algorithm, which gives the output of the sequence of keyframes, and those keyframes are fed into the image captioning model that was trained and tested earlier as a part of generation of caption from the static image and file. And finally, it is the observation that was made in the efficiency and accuracy of this model, how perfect is that when we use the same model which was used earlier in case of video file. This section, we try to cover the methodologies used for developing this thesis work. In this, the thesis image caption model is created to extract the features from the standard set of images based on the Flickr 8K and 30K and the video files. The captions are first loaded and cleaned and processed by processing the text, and then that is stored into a file. Then once that text are cleaned, then the vocabulary of words is created, and it is kept in the dictionary that is used by the model later to generate the caption. Then we have extracted the features from the images by using the CNN. The created sequence, we have created a sequence generator to use by this model for generating the sequence of word, and built a model to process the inputs from the extracted features and predict the next set of word to generate the sentence. The language summary takes care of previous words to generate the next set of words by using the LSTM. The merge model, which you can see here, is basically combines the feature extracted from the CNN and the output from the LSTM, and then that goes into the dense network, and then from the dense network is basically getting processed, and finally a softmax activation function is used for and the categorical cross entropy loss function is used to minimize the loss. A sequential based keyframe are used for to extract the keyframe from the video, and by comparing the difference between the two consecutive frames. The difference, if the difference is greater than some threshold value, then the frame is considered as keyframe, and if the extracted frames are then given as an input to the same model that was trained earlier to generate the in this section I'm trying to cover how my model is. My model consists of 8 layers, and the very first basically it is divided into two parts. One is processing the text, and another part is processing the image. So processing the image, that is done by first by using that global max pooling 2D layer. And why I have used it, because this model summarizes the presence of each and every feature in an image. Next, this output of the max pooling 2D layer is then given to the dense layer, which is basically to make sure that the linear operation happens in each and every neuron in the layer that are connected to, and each and every input to the next layer. It basically converts the extracted features into the array of matrix array. Then the output of the dense layer is given into the repeat vector layer, which is used like an adapter to fit the encoder and decoder parts of the network together. And while processing the text, the very first thing is that embedding layer is used on the text data to capture the relationships of the languages that are very difficult to capture. Then the LSTM layer that has been used to process the data by passing the information as it propagates forward by remembering it for a longer time. Then the time output of the LSTM layer is then fed into the time distributed layer, which is used to apply the same layer for several inputs, and it produces the one output per input to get the result in time. Then the output from both the extracted features and the words that got generated, then it is basically fed into the LSTM network. This is done by concatenation layer, which combines both the feature extracted by CNN and the output that is coming from the LSTM. Then the output from this concatenation layer is fed into the LSTM network to generate the output that is interpreted by the dense layer, next dense layer, and one at a time. A softmax activation function is used, and a categorical cross entropy loss function basically minimizes the loss along with the Adam optimizer that has been used to improve the performance. The slide specifically we are trying to cover the results and the output that has been generated from the model. You can see that the left hand side graph that shows the model performance better when it is trained with more epoch, and the loss and the accuracy of the model is poor when the model is trained with less epoch. The model performs poor when we trained with less amount of data, that you can see in the extreme right hand side diagram. So you can see the middle diagram, which basically shows the accuracy. You can see that accuracy is getting increases by by improving the epoch. The number of epoch it passes through, it improves the accuracy. Now, if you look at it in the next slide, the outputs that got generated from the model in the first one shows that in meaningful sentence generation, when it is trained with the globe data, and the model performs poor for the images when it is extracted from the videos by using the keyframes. You can see it in the middle one. Then at the end, the model generates not meaningful sentence when it is trained with lesser data. So all the three scenarios that has been observed and shown in this slide. The model sometimes generates not meaningful sentence when there is a complex image. You can see in the last one also the same performance. Mm, and in the next slide we will talk about the conclusion and the future set of work. Conclusion is, from the performance point of view, the various datasets that we were analyzed, and the challenges are, as a huge set of data, loading the data and process the data is as a painful job when using a single machine, instead of if we can use it in any cloud environment or very high configuration machine, then it will be very helpful. Training the image with a huge sentences and creating a huge vocabulary or dictionary may solve this issue for generating the meaningful sentence. Performance also can be improved by executing the same model with higher configuration computer assets. Insufficient vocabulary, the observations what I have made is that insufficient vocabulary making the description meaningless. Images with a complex scene and the image captioning giving description to the unrelated to the content. Key frame extraction is an ill-defined problem due to the lack of better generalization and in image captioning model. Generated summary may not be meaningful all the times. What can be the future set of work? Because this model can be further leveraged by training the language other than English, and performance can be measured. Unsupervised learning can be leveraged for both the images and as well as the text generation for improving the image caption generation. As an approach for generating the sentence from a dictionary by extracting each and unique feature from the image, that is another options can be led. And then an approach by extracting the unique image, a unique object from the image by using the different libraries and feeding the same into the model for generating the sentence, that can be taken care. And finally, the least not by the least, is that model can be tried by training the huge set of descriptions, so that enough vocabulary should be available to avoid the scarcity of the words and defining the features and the relations. And finally, I would rather to say thank you to everyone for hearing this video. And if you have any feedback or any comments, you can always contact me on this email ID.